Welcome to the Daily Recall Show. I'm your host, Vasily, and today we will be talking about two different methods to solve problems. Okay? So we already covered what is the ideal state law in past couple of videos, and just to recap, the ideal state law suggests that in any technical system out there, the ideal state of a system when the function is being performed flawlessly, but the form is absent. Okay? So that's the ideal state law. And basically all systems, they kind of develop towards this ideal state of formless function. And if you don't remember, there was a story of the Venus satellite where the guys had to put in the gadget or to the satellite, and they basically discovered that there was this weight in the satellite, the balancing weight, that they could replace with this gadget so that the gadget would perform two functions instead of one. And that was great because the weight was redundant and they just got rid of it. Okay? So the ideal state law basically pinpoints to a very interesting distinction between two different types of problem solving. And the first type, the first way to solve problems is what is called the designer approach. And the designer approach is basically saying that, okay, we got to do X, right? And to perform X, to do this function X in the product that we're developing, we need to add new feature or add new capability or add new material, whatever that is in relation to what we're working on. So in product development, that might mean that we need to add new feature to our website, or we need to add a new feature to our mobile app to perform this function, okay? And there is this whole another approach of solving problems, which I believe is much better because it fits the ideal state law so nicely. And if you don't remember why the ideal state law is so cool, it's because the ideal form, which is absent, right, is just perfect because it doesn't cost anything. There is no maintenance, it doesn't break, it's just perfect, right? When the function is being performed flawlessly. So this inventor approach suggests that the best way to do something is to figure out what we've already got in the system, like the materials that we already have in the field that we're performing, and just use those things to do the new function, okay? That's one. And the second would be to say that, okay, we've got a couple functions there, but we can kind of unite them into one function and create a multifunctional form. That's the video right there. So how do you use that? How do you use the inventor approach instead of the designer approach? Because the inventor approach is much better, right? And I'm going to share with you two examples of how this was done in two different domains so that you kind of get an idea of how to do this thing. And the first example is called the Slag tank problem. So the problem was that there was basically a tank of melting metal, right? Melted metal. It was very hot. And they had to kind of transport this tank with metal or somewhere else or in the manufacturing site. And the problem was that once they put in that metal in the tank, it started a reaction with the air, and the air was kind of cool. And there was this crust emerging on top of the tank with this melting metal. And that was a big problem because once this tank was kind of transported there, they had to crush this crust, and they had to kind of push through this crust and then make two holes and then kind of like somehow extract the melted metal out of that. So that was a pain in the ass. So what they did is basically the designer approach. Let's just solve this problem from two perspectives, right? The designer approach would be like, okay, how do we keep the metal from cooling down in this tank? We need a cap, like we need to put something on the tank so that the hot metal does not interact with the cool air, right? So that would be the designer approach to solve this problem. And that's how you get to figure out this new cap. You need to invent this cap, you need to manufacture it, you need to deliver it, you need to do all those things, okay? So designer approach adds new function, adds new form to the system. and therefore adds a bunch of problems. So the inventor approach instead to solving this problem is basically by doing the following. We need to understand, we create the model of the problem, right? And the model of the problem is that we've got this metal, which is in the melted state, are in a tank, and it interacts with the cool air. So the question would be that, okay, can we somehow tinker with the process of putting that metal into the tank so that the best kind of cap that we can invent would be the cheapest one, would be the cap from the metal instead, okay? And that's how you get to arrive to understand that the best cap on this metal would be the foam, right? So, and how do you do that? How do you do the foam? It's like very simple. You just need to sprinkle a little bit of water when you're putting that metal into the tank, and then the foam emerges on top of the metal, and that's how you get a very natural cap which prevents metal from cooling down and which prevents crust from emerging on the top. And that's basically the solution. So the inventor approach to solving this problem is much better because you don't have to like create this whole new cap, and you don't have to spend much time doing that. Another problem where the inventor approach would work much better than the designer approach, it's called the frozen fish problem, the frozen smoked fish problem, okay? So in Norway, where they have a bunch of fish, they basically smoke a lot of it, right? And when the fish gets smoked, it then gets frozen to be able to transport it to like large distances. And the problem was that you had to like create a package for this smoked fish so that it freezes nicely. And they could not use plastic for some reasons. And the metal cap was basically impossible to do because it's like really heavy. So the solution, again, the designer approach to solving this problem would be to, okay, we need to invent like some new material or manufacture it and then kind of wrap this fish into this package, right? But their inventor approach to solving this problem was to understand that first, the model of the problem is basically this fish, right, interacting with hot air instead of like cold air in the problem before. And then, but when you have created the model of the problem, it's much easier to see that, okay, it's actually the same problem that the one before. So we also need the foam because the foam prevents the metal from cooling down, and it prevents the fish from warming up or when it interacts with this air. So the solution is essentially the same, but it's derived from a different resource, which was already present. The solution was to use the liquid that they use for smoking the fish and add a bit of gas, nitric dioxide, so that when the reaction happens, the foam emerges. And then you basically, after you like frozen this fish, you wrap it in this foam and it keeps frozen very nicely and is able to be transported into larger distances. So that's their inventor versus the designer approach. And whenever you get to solve a problem, it's very useful to ask yourself, am I thinking from their designer perspective or from the inventor perspective, right? Because it's much better to think from the inventor perspective, because again, this whole idea fits their ideal state law of technical systems, of how they develop and evolve, and it's much cheaper, it doesn't cost anything, and it allows you to do amazing things. Thanks so much for watching, and see you tomorrow.